Hi everyone, I'm Sunish Surendran Kanaibath. In this session, I'm going to talk about the topic Googling the next normals in modern engineering. So, as the title says, everybody is staring at the new technologies, and new technologies are keep on changing. So, I hope this session will help you to understand the new technologies and you can implement in your environment. So, this is me, Sunish Surendran. I work as a research and development engineer, and I have an experience of 7 years in IT industry. This snippet is taken from my GitHub page. So all the code which I am showing today in this session will be available in this particular GitHub page. You can have a look at it after this session. Coming back to our topic. To discuss about a DevOps journey, I have to develop a software and I have to deploy it also. So it is a complete flow. So I divided this session into three parts. The first part is developing the web service. The second part is converting into that web service which we created into a container. And the third part is deploying that in a container orchestrator environment. Here we are using Kubernetes as a container orchestrator. These are the tools actually we are going to discuss in this session. Golang for the product development, Python, HTML, CSS, and JavaScript. The last three will be used for the front-end development. And for the deployment, I'm using Groovy, Helm. And for the infrastructure, I'm using Jenkins as my CI/CD server and Kubernetes as my container orchestrator and Docker for hosting these containers. So let's go and discuss about the part one, which is developing the web service. Before going to that, we have to compare what all software we are using to develop our web service. Here in this case, in this session, I'm going to compare Go and Python. Why? Because we are using Go and Python for developing the web service. This is the basic comparison of Python and Go. Python is pretty old and it is released in 1991. And what about Go is, it is released in 2009 and it is pretty new to the industry. Python is also known as an interpreted language because we can open Python script and we can edit it and we can save it. No need to compile it. So it is also called as a scripting language also. In the case of Go, it is a compiled language. So we have to type the language and we have to compile it, then get the binary out of it. And Go almost look like a C language. And the next comparison is Python is dynamically typed language and Go is statically typed language. That means that Go, before compiling it, we have to be define all the types of the variables. So if we didn't define, the Go will throw an error before compilation. So let's see what actually we are trying to achieve by using Go and Python. We are making two web services, one with Go and one with Python, and it will be pointing to a front end which is made up of CSS, HTML, and JavaScript. So this is the high level view of our product. So if we zoom into the front end, it looks like this. The front end have two parts. One is the Go and one is the Python. The Go have two buttons, sequential and concurrent, and the Python also have two buttons, sequential and concurrent. So what happens when the user press the sequential button? When the user press the sequential button, there will be a REST call going to the web service, and this web service will process the call, and it understands that this call is coming because the user pressed the sequential button. So it have to run a task in a sequential way. And what is the response given back is the time took to run that particular task. Let's think a task is taking a 1 second to run, and we are running it in 4 times. So the total time it took is 4 seconds, right? And for the concurrent button, if the user press the concurrent button, what happens is the call will go to the same web service, and we have a logic written inside the web service to route it, and that same task will run in a concurrent way. So the task which ran for 4 seconds will be now running only for 1 second or almost 1 second. So that is the logic. And the same happens in the case of Python also. we have two buttons, sequential and concurrent, and whenever the user presses sequential, the call will go to the web service and the response will come back and it is shown in the UI. So this is the feature of our product. Let's go and see how the logic it is written inside the web service. So this is the web service internal architecture. The left side is the Python and the right side is the Go. The Python will be, with the Python web service will be listening to the port 5000. So that's why you can see I marked port 5000 here. And the Go will be listening to the port 9090. And we have a router. In the Python case, I'm using Flask. So we have got a router Flask handler, which will route the traffic according to the request coming to it. So in our case, the user is pressed concurrent button, then the router knows that it should be passed on to a function concurrent. And if it is pressed sequential, it have to be routed into the sequential function. The same happens for the Go also. There is a router which is, we are in the Go case, we are using the router default handler, and according to the button press, it will be going to concurrent function and it will be going to the sequential function. And one more thing I have to tell here is we are using the concept of struct and interface in Golang. So struct is almost like a class in Python, and interface method is like abstract class. I cannot say that interface is like abstract class. It is almost look like an abstract class. And interface actually are named collections of method signature. And the struct is a user defined data type, and it will combine other data types into a single data type. So that is the struct and interface, which we can compare into Python like a class and abstract. So that's why I used all those things like side by side. We can go to the code level and just have a look at the code before going to the part 2. So you can see that I have Python script open in my left side, and my Go web service written in the right side. So as we told, the Go will be listening to 9090 and the Python will be listening to 5000. And in the Python, to get this functionality, I am just importing the library Flask. And with the router routes according to the call coming to the Python. And the same happens in the in the Go side also. The HTTP handler have the responsibility to route the call into its own functions. So the sequential way and the concurrent way, how that is handled. Sequential, you know that a for loop is enough. Like a task is coming, it have to be running 4 times. A for loop will help us to do that. That logic is same in both Python and Go. But when it comes to concurrent, it is different. In Go, I'm using Go routines to achieve that, and also the channel concept. So if I go to the function concurrent, you can see that I have defined a Go routine function, and it is running and it is giving the response back to the channel, and the channel is capturing all the response from that particular Go routine. And we are calculating the elapsed time here, and this elapsed time is actually sent back to the user UI, like as we discussed in the UI part. So my actually the project looked like this. It have a Python folder and also have a Go web service folder, and it contains the particular web services. And for the front end, I have another folder which have my CSS, Java, and index.html inside this particular folder. So if I look, if I want to convert, if I want to check in into the repository, what I did is I create for all this folder, I create a separate repositories. Why? Because any change happens to this particular code, this repository have to be updated with the changed code, and there should be a pipeline running for that particular change, right? So for getting that logic, I have marked this Python web service as a repository in my GitLab server, and in this Go web service as an another web service, and front end as an another web service. So let's have a look at the GitLab. This is my project, and the project contains this many repos. As I told before, it have the Python web service as a separate repo, Go as a separate repo, and front end as a separate repo. And for each, there will be a hook configured. I can show you that now. Let's the okay. If I go to the settings, you can see that integrations, and in the integrations I have configured the particular hook. You can see that this is the IP of my Jenkins server, and this will trigger a job which we created, like not job, actually it's a pipeline. So whenever there is a change happens in this particular repository, or there is a push event or a merge request or a not event, it will just triggers that pipeline in the Jenkins. So in this Jenkins server, you can see that there are two folders created, CI and CD, and this CI part consisting of three jobs pipeline actually, and this pipeline is pointing to the hook. So whatever changes we make in the repo, this pipeline will get triggered. So that is a concept. So what this pipeline does is it will build that images of that particular repo. So let's go back, and we are entering to this part 2. Actually, we created the web service. Now we have to convert that web service into a container image, and that container image can be deployed into the Kubernetes clusters. So how to convert the web service into a container image is like as normal, like we seen in the internet. We have to make a Docker file for that. In our case, the Docker file have a little change actually. Like for the Go, I am creating a Docker file which is actually called as multi-stage Docker file. So it will, as the name says, it will have multiple stages. The first stage, and it will have a different sub stages. And the first stage here in my case is you can see that. I will take this part as a first stage and this part as a second stage. In the first stage, what it is doing is it is just pulling the Golang image, which is a Golang Alpine image, as a builder, and I'm copying my all the code which I written into that particular image. Once I copied into that image, I am just running the go build command, and my web service name I'm marking it as web service. That's why you can see the line number 10, run go build and web service. So I will get the web service created from that particular image. That completes the first stage. In the second stage, what it does is the compiled code will be taken from the first image and it will be copied to the second image. In this case, I am using the second image as an Alpine image. So you can see that I am moving to the working directory /app and just copying from builder then to the apps directory, right? So actually the result of it is I'm getting a Alpine image which hosts my web service. And what is advantage of using this multi-level or multi-stage Docker file is, if I just directly use Golang for building and hosting my web service, then it will be having a size of 50 MB to 70 MB, which is pretty high, or it can go above also, like around 100 plus MB. So the concept what we are using as a container should be like always a small image. It should use a small image. So in this case, it is built in an one image and it is copied to another image. And Alpine, as you all know, it is pretty small. So when we are building this particular image, it will come up to only 10 MB in size. So I prefer to use multi-stage Docker file always because it will give me a very less size of Docker image. So if I move to the Python, You can say that here I am not using a multi-stage Docker file. Why? Because Python, there is no compilation required. Anyway, I need a Python to be installed in that particular Docker container. So in this case, using a multi-stage Docker file is not make a sense. So this is a straightforward Docker file. Even if I go and see the front end, Docker file. This is also a straightforward Docker file. I'm using Nginx as a base image, and I'm just copying the HTML and CSS and JavaScript into it. You know that all these three doesn't require any compilation. So only the multi-stage Docker file I'm using in the Golang, because it is can be compiled, and it will give me a less space actually in my Docker registry. It is only requires a less space. So wherever can be used, please use it. I suggest to use Docker multi-stage level file, actually Docker file. So this is how we converted the web services we created into a container image, and this image will should be pushed into the Docker registry. So in our case, actually the Docker registry is the Docker Hub. For this session, I am using Docker Hub as a registry, and if this is done by manually, then it takes more time, right? So for this action only, I am using the pipeline concept. So let's this now we can move to the part 3, the creating the Docker image and deploying into the Kubernetes cluster, which have that operation side. The part 3, deploying the container into Kubernetes, right? So this is the architecture I just talked about. We have separate repository for each of the microservice, and whatever changes we do, a pipeline will be getting triggered. That's why you can see that all it is connected to the CI pipeline. CI pipeline, and this what this CI pipeline does is it will understand that it is called from front end, so it will create the changes created in the front end, and it will be creating a Docker image, and that image will be pushed into the Docker image registry. Here in our case, it is Docker Hub. Once it is pushed to the Docker Hub, then it will trigger the CD. The CD take care of how to deploy it to the Kubernetes cluster. So how this both is connected is from this job there is a call going to the CD pipeline. So now we can explore how this particular pipeline is created and what is the logic written inside it. We can go back to our Jenkins server. This is our Jenkins server, and it, as I showed before, it have three jobs created, and these three will be getting triggered whenever there is a change in the repos. Here, front end, Go Web Service, and Python. So let's go and explore the Go Web Service. We can see that actually this pipeline is calling a Go web service.groovy file. So this start explaining about the concept of Jenkins, which is called as like pipeline as a code. We can write all the pipeline as a code level, and in our case, I'm using Groovy. So we can use, as well as we can use YAML also. There is a plugin released recently. I just tried it, pipeline as an YAML. After installing that plugin into your Jenkins machine, you will get an option like pipeline as an YAML also. So you can write the same pipeline which you written in Groovy in YAML also. But I see some of bugs, and the plugin is in development. So that's why I'm not using for this demo for right now. Now, actually, it is pointing to the CI/CD repo in our GitLab, and it is using the script pipeline Go Web Service CI pipeline Go Web Service dot Groovy. Let's go and see what is inside that particular Groovy script. This is my Go Web Service repo. I'm not keeping my CI/CD related things in this repo. I'm just keeping the code which we developed, the Go Web Service. All the CI/CD scripts are kept under the CI/CD repo. So we have to go back, and inside CI/CD repo there is a folder called pipeline scripts. And as we mentioned inside the Jenkins, here I am just calling the Go CI pipeline Go web service dot groovy. So this is the Groovy script. You can see that there is a library command. So what this means is Jenkins have a one more concept called a shared library. So all the codes we no need to repeat or write it in the pipeline scripts. So the common code can be kept inside some file, and we have to put it in a folder called was. So Jenkins will understand that this is a common file, and it can be used and it can be called from other pipeline script also. In our case, common script which I'm using is called as a common itself. That's why I'm just importing the library common, and we have the stages like Sona, scan, checkout, build, trigger, CD, and it is under try catch. So any failure, it will try and catch and throw it properly. And inside the checkout, you can see that I'm calling a function which is written inside the common script. We can explore the common script. Going back to CI/CD repo, there is a was folder. Inside that, there is a common.groovy. And this common.groovy have all the function which can be called from any other Jenkins pipeline. And so in our case, I'm just using a checkout function. I'm calling checkout repo function with the with the parameter value like as GitHub, Golang. So it will clone the Golang repository using this particular command. So that is the concept of shared library. It is this the same checkout repo function can be used in my Python also. Only thing I have to change is the parameter value I have to pass. Like it have to be the repo name of Python. So it do the same job. So that is a good part of actually using the common shared library in Jenkins. So you can see that we are building the images and pushing into our Docker Hub registry. That is how our CI pipeline look like. We can go and see the stages of the pipeline. So as we saw in the script, it have a checkout, Sona, scan, build, and trigger CD. So this build will build the images, the multi-stage Docker file what I shown you, and that all the other Docker files also, and it will push to its Docker Hub registry. So this is how the CI pipeline is written, and the CD part. Coming to the CD part, let's go and see the CD pipeline. I kept it in a different folder itself, so it is easy for managing. That's why I'm using this kind of logics. This CD pipeline also will be pointing to one of the Groovy script. That is the here it is pointing to the script called CD pipeline dot groovy. Let's go and explore what that particular CD pipeline actually have the logic. The pipeline also have different stages. One is to check out the CI/CD repo itself and update the Helm. So I will come to the Helm part. So it will now you just think about it will update the Helm, charts, and it will do some deployment. So in our case, actually the product deployment happens through Helm. Helm is a packaging manager. It will pack the complete product into one chart, and we can use the chart to just deploy that application into Kubernetes cluster. It's a very good concept, and it is widely used nowadays. So we are also using the same. We are building a chart and we are deploying into the Kubernetes cluster. For each time when we are deploying into the Kubernetes cluster, actually we have to make a chart. That's why I'm writing some logic inside my Groovy script to make the chart and to deploy it. And it should know, right, the chart should use which docker image to deploy. So all this logic I am writing in my cd groovy script. Here I am using actually inside the groovy script I am writing a shell script actually, and this shell script will do the all the required actions for the cd. In our case, I want to introduce you one more tool called Kind. So here I didn't deploy any Kubernetes, a full-fledged Kubernetes. I'm just using the functionality of Kind. If you Google it, you can see that Kind. Kind means like Kubernetes inside Docker. It's a pretty good tool. All the developers can just explore it. Even operation team can explore it. So if you want to learn about Kubernetes or anything, Kind is the best tool I feel, because you just need a Docker running in your machine, and Kind will be get deployed above the Docker. So concept wise, it is pretty nice. And here also for this demo, I'm using Kind. So all the things, all the clusters is created with Kind. Here I have a cluster which is actually already this product is deployed, and so that is actually deployed inside Kind cluster. So this is how the flow looks like. We have repositories, and we have CI pipeline that we just saw now, and we have a CD pipeline also, and it is pointing to the cluster. In our case, we are using for Kind as our Kubernetes cluster, and this part Docker image registry as a Docker hub, and I'm creating the Docker images using the multi-stage Docker concept for the Go. So let's see how it works by changing something in the front end, and how it works actually. For now I already deployed that application. So if I press on my product IP, it is launching my application. You can see that as we expected, it have two parts, the Golang as well as the Python, and it have a two buttons called sequential concurrent, and it have two buttons called sequential concurrent. So it will do the required jobs what we are expecting. For now, to see the flow of CI pipeline, just explore like we will do a change in the front end repo and see how fast it is getting reflected in the page. Let's do that. Before going to that, I want to show you like what is the uh, currently running the pod. What are the currently running pod, and which are the images used by the pod to run it. So if I do a change the pod, if I do a change in the repo, it should also change the version of Docker images used by the pods, right? So this is my Kubernetes cluster. So you can see that the pods are running. Let's see the version used. kubectl edit pod. Okay, just get pods. This is the latest pod name. Okay. You can see that the image used by this particular pod is front-end v9. So the tag name is v9, and it is using the front-end Docker image, the name with front-end, and the tag v9. So if I do any changes, this v9 should be like v10 or v11, right? According to the build pipeline. I can do some changes in the index.html. I will change the Golang name into Golang test for now. So I just committed the change. Before pushing the changes into the repository, let me show you the pipeline build number and in Jenkins. The CD, we can open the CD in one window and CI in the other window. So here the changes are done in the front end. So that pipeline which will get triggered when I'm pushing the changes will be the front end pipeline. And you can see that the last build successful build is 9. So the next new build will be in the number of like 10, and we are using this logic like we are taking the tag name from the build number. So here the tag created will be v10, and then the v10 should be deployed into the Kubernetes cluster. So let's do the check-in now. I push the changes. You can see that within seconds there is a build started triggering. So it started checking out the repository, and a build is getting triggered. Let me see the logs. Yes, we can see that there is a Docker push command happened, and it is pushing the Docker images with the tag v10. And once it is pushed, you can see can see that the CD also will get triggered. I think it's already over. It's already got triggered. You can see that build number 52 is the one which got deployed as part of CI trigger. So coming back to our UI, we changed this Golang actually to Golang test. Let's see it is got reflected or not. We will refresh and see. Yes. Once I refresh the page, the Golang test is reflected, and this is achieved with the help of our CI/CD pipeline. And let's go and see in the machine. We can see that it is current. The ports are running with the image front end v10. That's why the change we are seeing. So you can now understand that how fast the changes are pushed into the environment. We will just go back. Okay, so this really helps for the developer. Like if any changes he wanted to push into the production environment or any other testing environment, he have to just do the changes in his local machine and have to check in. All the other things will be taken care part of the CI/CD flow. He don't need to worry about what is actually happening at the backend, creating the Docker images, pushing to the Docker registry, and pulling down. So only the missing part here is how it the CD part, how it got deployed. So as I told before, we are using the concept called Helm, and Helm is helping us to achieve that. These Helm charts are created and kept inside my Docker CI/CD repository. You can see that there is a folder created for Helm chart, and Helm chart structure is like it have templates and it have chart.yaml and it have values.yaml. This chart.yaml is the one which we are pushing actually using the Helm command. Helm install chart.yaml. If we give, it will install whatever we mentioned this chart.yaml. It is like an yeah, it is the first hit point in the Helm. It have a version and also it have a name. So what all these templates? These templates are the one in the Kubernetes. Actually, we call it as a YAML, Kubernetes YAML. Whenever we deploy anything inside Kubernetes, we can deploy it using YAML also. So we are using YAML for deploying our Python, Go service and front end. And each deployment should have its own a node port also. That's why we are accessing it from outside, and it's working. So this values.yaml, why we are using is like we should tell them how many number of ports should be running, how many, what is the version should be used for the deployment, and also for that actually this values.yaml is helping us, and we have a logic in order to update this particular Python web service tag value. Each time whenever we trigger a CD pipeline, it will come and trigger this value according to the last successful build number of CI. That's why when I checked in, it took the V10 as the value of the front end tag, and it got deployed into the cluster. So this is an amazing concept of Helm, and it is really helping us to pack the complete package into one. Now actually we can actually see the functionality of our the web page what we developed. So bringing our Golang web service, and we can just load it, reload it. We have two sections. One is called as a Golang, and the other one is the Python. And the Golang have two buttons as we discussed. And if I press the sequential button, a task will be running in a sequential way, and it should give a response. So you can see that the task which ran is 4 times actually, and it is taking a time of 4 seconds. If I press in the sequential button in the Python section, it also will run in a sequential way, and it should return the time it took to run. You can see that Python took around 4.002 seconds. So comparing both, I think Golang is taking much more lesser time. If we press the concurrent button, it use the go routine concept at the backend, and it should give the same result like time it took to run it. So it is almost 1 second, 1.004 seconds, and in the Python, when I press, it is taking 1.0222 seconds. So that is the difference actually. In the performance, Go is pretty much faster than Python. So this is a very small use case for comparing Go and Python, but it still shows you like how fast the Go is. So Go can be used in high processing web services. Also, like if you want a high speed response, so Go is a best suit for that. So this brings us to a conclusion, like which software we can use for development, and also what is the flow we have to follow for a product development to give a much reliable and a high speed deployment. In our actually this session we talked about developing the software, what we showed now, and how to deploy it also into a particular cluster in a good manner. So if we in this session I didn't show you like a unit testing integrated and all. So in your environment, if you integrate a proper unit test and smoke test, you will have much more confidence to push your code directly into the production environment or production cluster. So if any problem, the pipeline will definitely will fail by saying the issue is because of that, and it won't push the changes into the production environment. So this complete DevOps flow is helping us to achieve and drive the software development in a very much higher rate, and also easy to catch the problems in an early stage. So I hope this session give you a brief idea about a DevOps flow, like developing and operational side also, and it also made you like it introduced you the kind and shared library concept and all. So summarizing our session, the takeaway from the session, I can tell the comparing the Python and Go, and also the concept like interface struct, HTTP handler, and Go routines, what we used for developing our web service. And also for in Python, we used Flask and multiprocessing module to develop the Python web service. Both this web service will be available in GitHub, so you can have a look at it, and also you can contribute to it. And we also talked about a concept called a multi-state Docker file, which help us to reduce the size of the Docker images. And if in the Jenkins side, we discussed about the shared library concept, which is really helping for the CI/CD deployment. And also in the cluster side, we introduced Kind, which is really amazing tool. I suggest everyone who is listening to session to try it out after this session. The Kind is a very good tool for to learn Kubernetes, and also for developers to deploy their application into Kubernetes cluster. So if any question, you can reach out me in my GitHub page, as well as in my Twitter page. And I hope this session will be really helping you to understand the DevOps world, and learn user time. I know that everybody will be sitting at home and learning new things. So I think this session will help you to learn new things. Thank you so much listening in this session, and any questions, let me know. Thank you.